This is lesson 4.55, arithmetic sequences. So in this lesson, you're going to learn how to identify and write arithmetic sequences explicitly and recursively. Arithmetic just means, you might think of this as like arithmetic. Arithmetic means adding or subtracting. So basically, arithmetic means that you've got a linear sequence where you're increasing by the same amount. So you're increasing or decreasing by a constant amount. And that constant amount, remember, is called the slope. So here, a sequence is a set of numbers written in a given pattern. Complete the table below and answer the following questions. So if your numbers, your n goes from 0 and then down to 3, the next one would be 4 and 5. And then in the f of n, the y, goes 0, 5, 10. So you're adding 5 each time. So this would be 20 and 25. So complete the table below. Okay, so what type of function is this? This would be linear because of the reasons we stated before, because the slope is 5. You have a slope for the whole thing. The pattern can also be called an arithmetic sequence because it has a common difference. Please make sure that you're writing these terms down. Common difference basically just means the slope. So the difference between the y's is common through the whole thing. What is the rate of change? That would be 5 because that's the slope. And then write the equation of the function. So here our equation, the y-intercept is 0 and the slope is 5 because when x is 0, y is 0. So the equation would be y equals 5x. So find f of 25. Well, we would just do f of 25, just plug in 25 for x. So 5 times 25 is equal to 125. Right? And this statement here says a set of numbers in a specific order, each having a common difference, represents a linear function. Right, so now we're going to determine if the sequence is linear or not. Tell whether the sequence is arithmetic. If it is, state the common difference in the next two terms of the sequence. So here we're going 5, 10, 15, 20, 25. This would be yes. And we say the common difference, we let that be the term d. So here d is equal to 5, and then the next two numbers would be 30 and 35. Number 2, 10, 30, 90, 278, 10. So it looks like here we're multiplying by 3. So if you're multiplying, then that would not be linear. Okay, number 3, that's 64, 32, 16, 8, 4. Here you're dividing by 2, so this would also be no because you're dividing. Number 4, 13, 9, 5, 1, negative 3. This would be yes, and your common difference would be negative 4, and the next two numbers, negative 4 because you're subtracting. And then the next terms would be negative 3 minus 4 is negative 7, minus 4 is negative 11. Right, so pretty easy so far. Okay, now we're going to learn how we would write one of these, or write an equation for an arithmetic sequence. So sequential notation uses subscript notation. And we've used this in class before. So a sub n, like x sub 1, y sub 1, that's like an example of subscript notation to identify each term. So your first term would be a sub 1, your second term would be a sub 2, your third term would be a sub 3, your fourth term would be a sub 4, and on and on. Similar to function notation. So it's kind of like f of 1, that's a sub 1, f of 2, that's a sub 2. So here's how you say it. So function notation, you say f of n. Subscript notation, you say a sub n. And always, please, make sure that the n is little. The n is not, it's not like a times n, it's a sub n. It's just notation. You're not multiplying a times n. And it should be always noticeably smaller than the a. So how to use it, kind of basically the same. So if you're finding f of 4, you plug in 4 for n. So 2 times 4 plus 1 would be 8 plus 1, which is 9. If you're finding a sub 4, you just plug in 4 for n. Just the same thing. So 2 times 4 plus 1 would be 9. And then how to write it as an ordered pair. The x is n here, and your y is f of n. So this represents your input, and f of n represents your output. For subscript, or for this notation, the n represents the term or the number of the term. So like first, second, third, fourth, and then the a sub n represents what the actual term is. In the pattern. So the x is the number of your term, first, second, third, fourth. The y is what the term actually is. All right, and here I'm just going to prove to you how to get the arithmetic sequence. So arithmetic sequences are linear functions. So let's take the point slope form for a line and write an equation using 1 comma a sub 1. So that represents the first term, a sub 1, for x1, y1. So remember, point slope form is y minus y1 equals m times x minus x1. All right, but instead of x1, y1, we're going to replace that with 1 and a sub 1. So we're going to do y minus a sub 1 equals, and now instead of d, so we're using the point 1 comma a sub 1, and well, actually we'll get to that in a minute. And instead of m, we're going to use d. Well, x sub 1 is just going to be 1. All right, and then instead of x comma y, we're going to use n comma a sub n, because those are the variables with the sequence, arithmetic sequence. So y is a sub n. So we've got a sub n minus a sub 1. And then n is x, so n minus 1. Okay, and then we're going to solve for a sub 1 by adding the a sub 1 over. Sorry, we're going to solve for a sub n. So then the final equation, and now this one, you're going to put the a sub n first, actually. So a sub n, we keep mixing up a sub 1 and a sub n. Put the a sub 1 first, and then plus d times n minus 1. Now, if that seemed overwhelming to you, all you need to do is write down this equation and know what the terms mean and know how to use it. You don't need to know like all the proof for it. You don't need to do that each time. You will always be given this, so make sure you have it conveniently in your paper. If you're an e-learner, if you're in class, you'll have it written on the board, but this is something that you'll need to know. So a sub n represents your nth term. Okay, it's like the y value. A sub 1 represents the first term, and that's kind of like your b, okay? Your first term. D is your common difference. Or your slope. And then n is the number of the nth term, which is kind of like your x. Right, so make sure you write all of this down, the equation and what everything stands for. Okay, now we're going to do some practice. So write a rule for the nth term of the sequence. So you've got -4, 1, 6, 11, 16, and then find a sub 100. So Here, let's identify everything we know. So we know that a sub 1 is -4, and we know that the common difference, you're increasing by 5 each time, so the slope or your common difference is 5. Okay, now let's write the equation. We're going to keep a sub n in our equation. Okay, so we're going to say a sub n equals your first term, -4, plus the common difference, 5, parentheses, n minus 1. Okay, you're always going to have this n minus 1 here. Okay, that's not going to change. And that would be it. And then, in order to find the 100th term, you would say a sub 100, and then you're going to plug in 100 for n. So -4 plus 5 times 100 minus 1. Okay, so this is going to be 99. Okay, and then 99 times 5 is 495. Oops. And then -4 plus 495 would be 491. So that would be the 100th term. So when the x is 100, the y is 491. Okay, part B. 13, 9, 5, 1, -3, and then find a sub 100 again. So here, your first term is 13. Your common difference is -4, because you're decreasing 4 each time. So then the equation would be a sub n equals 13 minus 4 times n minus 1. And then for your 100th term, this would be 13 minus 4 times 100 minus 1 is 99. You can either type this on your calculator, and that would be -387. Okay, and then we're going to do one more example here. To find the nth term of the given term. So you're going to figure out, you're going to solve for n if you know a sub n. So basically you're working backwards. So remember how sometimes we would solve for x if we were given the y? That's exactly what we're doing here. But the first thing we'll need to do is make an equation. So here, based on this, our first term is -12, and then your common difference would be 7. So then the equation would be a sub n equals -12 plus 7 times n minus 1. Okay, so then we're going to substitute 72 in for a sub n. All right, so there are a couple ways we can go about this. One thing that students like to do is, okay, you're trying to solve for n. So one thing you could do is add over the 12 first. So then you've got 84 equals 7 times n minus 1. So one option is you can divide both sides by 7, but a lot of times students will want to distribute the 7, and that's totally fine. So let's do distribute the 7. So I'm going to write up here, 84 equals 7n minus 7. Okay, and then solve for n, two-step equation. Add this 7 over to get 91. And then 91 divided by 7 would be 13. Okay, and then if you were to write that as a coordinate, it would be the 13th term is 72. Okay, and obviously you're not going to want to try to figure out that by hand. That would be too tricky. All right, let's do a little more complicated example with fractions. So here we're doing the same thing. They give us what the nth term is, and they give us a pattern. So here our equation would be your original term is 3/4. And then here, think about 3/4. Let's convert these all so that they have the same denominator. Okay, how about the denominator of 8? So this would be 6/8. 1/2 would be 4/8, and then this would be 3/8. So actually your common difference is -1/8. You're decreasing 1/8 each time. So it's -1/8 times n minus 1. And then you're going to replace -7/2 with a sub n. Just going to put that in there instead of rewriting the whole thing. All right, so go ahead and then subtract the 3/4. Okay, negative, you can do this in your calculator, or negative 7/2 with a denominator of 4 would be negative 14/4. So negative 14/4 minus 3/4 would be negative 17/4. And then equals negative 1/8 times n minus 1. Okay, you can distribute the negative 1/8. This would be plus 1/8. Subtract the 1/8. Oops, 1/8, not 18. And then this would be negative 34/8. We want to combine these two, so that would turn into negative 34 minus 1 is negative 35/8 equals negative 1/8 n. Okay, so one thing you could do is multiply both sides by negative 8, the reciprocal. And then when you do that, the 8's cancel, the negatives cancel, and you just get 35. Now, let's think about this for a minute. N should always be positive. You can't have a negative term number. The actual term can be negative, but it's got to be first, second, third, fourth. Also, n must be a whole number. And that kind of takes care of the positive part as well. So you can't have a 1.5 term. Okay, so if you ever get a fraction or a decimal or a negative number for n, then you know you've done something wrong. And you should go back and figure out where you made your mistake or ask for help in identifying your mistake. All right, so there is another part to this lesson, but we're going to save it for day 2. All right, so with that, I hope you guys have a great day.